The satellite that changed what anyone thought was possible for quantum networking is gone. Micius, the spacecraft that sent quantum keys between continents that proved a physics concept most researchers thought was decades away, has decayed from orbit. And the question that almost nobody in the West is asking loudly enough is whether the network built on top of it survived the loss. Before you file this as routine, end of life, housekeeping, hold on. Because which way the succession story reads determines something genuinely important, whether China has built infrastructure or whether it has been running a permanent science experiment dressed up as one. Those are not the same thing. And the difference between them is not measured in qubit counts or press releases. It is measured in what happens when a node disappears. According to program reporting, Jinan 1 now carries the space leg above an 80-city ground fiber backbone. The network is reportedly still running. But whether Jinan 1 is doing the job Micius did, at the same coverage, the same reliability, the same key generation rates, nobody outside the program has independently confirmed. The ground network is real and well documented. The space tier is a thin constellation of a small number of spacecraft, and what happens to the architecture when a space node disappears is the question the system has never had to answer until now. The United States and the European Union are both building toward the same ground plus space model. Neither has yet had to survive the loss of their first space node. That comparative gap is the actual story here. To understand what is being tested, you need to understand what Micius proved in the first place, and why proving it from space was the hard part. Quantum key distribution is a method of sharing encryption keys where the security comes from physics rather than from math. The problem is distance. Push a quantum signal through fiber, and the photons that carry it start disappearing into the glass. Every kilometer of fiber costs you signal. By the time you have crossed a few hundred kilometers, the signal is too weak to use. You cannot simply amplify it the way you would a regular data signal, because measuring a quantum state to boost it destroys the information it carries. Ground fiber quantum key distribution hits a wall long before it crosses a continent. Think of it this way. Sending a quantum key through fiber over very long distances is like trying to whisper a secret through a straw that stretches across a city. The further you whisper, the more the message fades, and you cannot repeat it louder without changing what it says. A satellite link is like stepping outside and flashing a signal across open sky. The atmosphere still absorbs some of it, but the geometry works differently. A low-orbit satellite passes over a ground station for only a short window each night, but during that window, the signal travels through a thin column of air rather than through hundreds of kilometers of glass. The loss profile is fundamentally different. Micius demonstrated this over intercontinental distances. That result is among the most independently peer-reviewed claims in this entire field. It was published in leading scientific journals, reproduced and examined by researchers outside China, and it established that space-based quantum key distribution at operational ranges was physically achievable, not just theoretically plausible. That is the foundation everything since has been built on. Not a marketing claim. A verified physics result. The problem is what you do when the spacecraft that proved the concept reaches the end of its life. A single satellite is a demonstration. Infrastructure is something different. Infrastructure means that when any node disappears, the system degrades gracefully. It keeps routing, reroutes load, maintains service at some level. The distinction sounds abstract until you ask the specific question. Did the network keep running when Micius went dark? And did it keep running at the same level? The reported answer is yes. Jinan 1 stepped in, but reported and verified are two different things. Planned succession means the replacement spacecraft exists. Proven succession means the network maintains service quality through the transition, confirmed independently after the fact. No public peer-reviewed data has established that Jinan 1's key generation rates or coverage area match what Micius provided. What exists is program reporting that the handoff occurred and that operations continue. That is worth taking seriously. It is not the same as independent confirmation. There is also a structural question that the reported handoff does not resolve. The 80-city ground network and the space tier have fundamentally different resilience profiles. Losing one city node on the ground does not take down the rest. That network is genuinely distributed, built with multiple interconnected routes, the kind of mesh where traffic reroutes around a gap. The space tier is a different matter. A thin constellation of a small number of spacecraft is not a mesh. It is closer to a single bridge over a wide river. The bridge might be well built. There might even be a second bridge nearby. But when you are depending on a handful of overpasses for all your long-haul traffic, the loss of one is not a small rerouting problem. It is a gap in the route itself. This asymmetry matters because of what the network is actually used for. City-to-city links on the ground barely touch the space tier. Anything that requires a quantum relay over distances that ground fiber cannot reach, intercontinental links, connections between regions without fiber routes, depends on the space leg heavily. So the system is not uniformly resilient. It is resilient at one layer and genuinely fragile at another. Whether that fragility is acceptable depends entirely on what the network is being asked to do and how many spacecraft are available to absorb a loss. Now compare this to where the United States and Europe actually stand. The European Union's Quantum Communication Infrastructure Initiative, EuroQCIing, is an active program building toward a continental ground plus space architecture. The United States Department of Energy Quantum Network Initiative is similarly active, alongside university and agency efforts working toward the same model. Both programs are real. Both have funding, research output, and long-term roadmaps. Neither has deployed an operational quantum satellite relay. As of the latest available reporting, and the caveat here is real, because program timelines are not always fully public, no Western program has yet put a quantum key distribution satellite into operational service, which means neither has faced the succession test. Neither has had to answer what happens when their first space node goes dark, because neither has had a first space node to lose. That is China's actual comparative position right now. Not that it has proven its network is unassailable, not that independent confirmation of the Jinan-1 handoff exists. The position is that China is the only country currently taking the test that determines whether quantum networking is infrastructure or experiment. The United States and Europe are still building the rooms where that test will eventually be administered. Here's where the honest skeptic in this story has to speak up. If Jinan-1's performance is degraded relative to Micius, and the program is not reporting that degradation, the succession looks cleaner than it is. We do not have the independent data to rule that out. What we have is the fact that the network is reportedly still running, and no comparable Western system has yet had to make this transition at all. Those two facts can coexist. The absence of reported degradation is not proof that none exists. It is proof that none has been publicly disclosed. Here's my honest read. The people who say China has already won the quantum network race are looking at the wrong scoreboard. The race is not over, Western programs are active, and the Jinan-1 handoff is not independently confirmed as seamless. But the people who say this is all theater and no substance are not engaging with what Micius actually demonstrated in peer-reviewed physics, or with what an 80-city ground network actually represents as operational infrastructure. The real position sits between those two extremes, and it is less comfortable than either. China has raised its floor to the level of a system being actively tested. The rest of the world is still pouring its foundation. That is not the same as having won. But a floor that survives one real stress test, even an imperfectly documented one, is worth more than a ceiling that has never been touched. Every network that can lose a satellite and keep running has raised its floor. China is raising that floor right now, in real time, with a thin constellation and an unconfirmed handoff, but actually doing it. The United States and Europe are building toward the same architecture. When they deploy their first space nodes and eventually face their own succession tests, we will have a genuine apples-to-apples comparison. Until then, China holds the only data point that answers the infrastructure question from lived operational experience rather than from design documents. Micius went dark. The question it left behind is still lit. Here's what I want your honest read on. Put it in the comments because I genuinely want to know. Which matters more to you right now? The fact that China is the first to face the succession test at all, even without fully confirmed results on the other side of it, or the fact that the space tier is still thin enough that a second satellite loss could expose the entire architecture before the constellation is robust enough to absorb it? Both are defensible. Both shape how you read every quantum network announcement for the next 5 years. Tell me which bet you would back. Subscribe here. When independent confirmation of Jinan-1's operational performance surfaces, and it will, either through peer-reviewed publication or through credible third-party reporting, we will tell you exactly what it means for who is actually building infrastructure and who is still building experiments. Micius went dark. The question it left behind is still lit.